Hello everybody and welcome to our web meeting dedicated to European companies and organizations that are interested in implementing nanotechnologies with the support of the OASIS project. Myself, I'm Ramona and I'm your host for today. At Blumorfo, I'm responsible for investor activities. Blumorfo is industrial innovation partner of leading companies. We focus on delivering disruption from technology to new business models and designing new ecosystems for open innovation. Within the OASIS project, Blumorfo is responsible for the business coaching of supported companies, as well as the access to private investment opportunities. I'm very happy to have 4 speakers with me today. First of all, we have Sonia from Technalia, who is the project coordinator of OASIS, and she will start this webinar with an overview of the project itself and its different activities. After her part, I will jump in again and provide you with information about the current open call for Democases. And when this whole introduction part is done, we will focus on the showcases we have in OASIS. So we start with Javier, who is R&D project manager at Acciona, and he will explain you what OASIS is doing in the field of building. His presentation is followed by Stan, who will represent the activities of the Dutch automotive corporate VDL. And of course, last but not least, we have Gregory with us, and he works at Thales in France on supercapacitors and energy storage. Before I hand over to Sonia for the project introduction, just a few organizational things. So you might have noticed this webinar is recorded. So we will give you access to the recorded version as well as the slide deck. So don't worry, you will get all the slides we are showing today, latest tomorrow on the OASIS project website. This is an interactive webinar. So in the interface, you see a question box. Every time a question occurs on your side, just type it down. And at the end of the webinar, we have some minutes left. So we can take back hopefully all your questions and directly answer them. In case we do not manage to answer all the questions, of course, we will come back to you later. Before I hand over to Sonia, so those of you who have attended a Blumorfo webinar beforehand, you already know that we are always curious who's attending. So we would like to know what type of organizations are actually here with us today. And I cannot launch it. Olivia, can you launch the question? Okay, doesn't matter. We can try it later. So we will follow up here later today. Okay, it's open now. Perfect. So we see that 70% have voted. We wait 5 more seconds and then we can close. Olivia, I leave this to you again. So it's very impressive. We have 75% SMEs with us today, and 11% are research organizations, and 11% clusters. So now it's time to hand over to Sonia to learn what OASIS is all about.
Hello. Good morning, everybody. Hi, thank you very much for the introduction, Ramona. My name is Sonia Flores, and I'm working in Tecnalia within the Industry and Transport Division, and I'm the responsible for the multifunctional materials platform. Today, here I am presenting this webinar, and I am acting as the OASIS project coordinator. Yes, I would like to introduce the project. I'm very happy to coordinate this project. The project gathers 20 partners from 7 different countries. This project lasts for 44 months. Today we are in our 18th month of the project, and I'm very happy that the project is running smooth, even though the situation with this the world is passing through is not very easy. But I see very good collaboration among partners, and results are arising at the moment. So yes, I'm going to present you give an introduction to the project, what OASIS is, and the objectives behind the project. So now I'm going to share. I think you can see my screen. I will put the
not for the moment.
No. I guess
now
yes.
We see it. Yeah.
Thank you, Ramona. Well, okay. OASIS. OASIS is an open access single entry point for a scale-up of innovative, smart, lightweight composite materials and components. But why? Why the project? Why OASIS? Well, I think all the audience and all of us, we are aware that the European regulation with respect to CO2 emission is becoming more and more stringent. Sectors such as transport, energy, or construction are demanding lightweight and high-performance materials. Dense metals are being replaced by lighter metals or by polymer composites. However, each one individually does not meet all requirements for mechanical, electrical, and thermal abilities. Moreover, providing multifunctional products expected by these markets at right costs is boosting the need for further integration of functional elements in the structure, and at the same time setting up new processes to reduce cycle time and produce net shape parts. Nanotechnology can have the answer to this problem, but nanotechnology cannot easily be introduced into composite and metallic supply. Also, there is a lack of industrial scale manufacturing on nano-enabled products. These nanotechnologies are not present at sufficient quantities and are not currently produced for the high demanding industry. Also, the high cost these nanotechnologies and these intermediate nano-enabled products are presenting, especially for SMEs. So this linked to the need of tailored solution for each application, different chemical contents, production processes, etc., make the limited accessibility to SMEs to this development of lightweight and high performance materials. But nanotechnology, OASIS, and all that work in OASIS have found that nanotechnology combined with other key enabled technologies such as advanced manufacturing and advanced materials can lead to lighter and multifunctional structures, answering major European issues. However, the introduction of nanotechnologies in metallic and polymer composites in today's industrialized system as part of advanced materials and advanced manufacturing processes in different sectors depend very much on understanding all basic processes that will contribute to overcome the barriers that materials are currently facing to be introduced in the market. However, companies are facing several bottlenecks that should be overcome to access new technologies. The introduction of nanotechnologies in a certain part is limited by the need for specialized expertise. Also, investment costs and access to novel techniques are either too high or not a priority for small or large companies, respectively. On the other hand, individual companies or research organizations do not offer facilities and services covering the full development value chain and range of materials, intermediates, and products. In addition, the development of products based on lightweight, nano-enabled multifunctionality materials may require access to finance and an optimized business plan definition based on the prior exploration of the economic impact. The solution to this is found in the OASIS universe. OASIS intends to develop and organize a sustainable open innovation testbed for innovative scale-up of smart lightweight aluminium and polymer-based composite compounds and products, to which companies, and more specifically SMEs, can gain access through a single entry point, one-stop full package offer to develop, test, and adopt new lightweight, high-performance, multifunctional, safe, and environmentally friendly high-value materials, components, and structures in a cost-effective and sustainable way. OASIS gathers 12 pilot lines that will be upgrade or upscale, and they will operate under the umbrella of sustainable manufacturing. The concept of OITV is gaining weight Europe-wide. Shared innovation infrastructures constitute one of the biggest innovations for attracting and consolidating the collaboration among diverse agents in the innovation ecosystem. The enablement of access to testing and demonstration facilities has shown to be a catalyst for innovation. The Open Innovation Testbed, to guarantee easy and efficient access, offer its network of facilities and services through a SEP. OASIS offers an ecosystem of advanced manufacturing facilities. As a first approximation, OASIS gathers 12 pilot lines related to the development of nanotechnologies to be implemented in different metallic and composite parts to develop lightweight and high-performance materials. Pilot lines for nanoscale structures in unprocessed form with intrinsic functionalities, offering aerogels based on silicon nano-reinforced, nanoparticles and nanomaterials synthesis by way chemical routes, magnetic and flame retardant nanoparticles, and nanocomposites. 5 more pilot lines related to intermediate products with nanoscale features like baggy papers, carbon nanotubes treated thermoplastic veils, carbon nanotubes treated prepregs, sheet-to-sheet smart printed sensors and actuators, and nano-reinforced metallic alloy ingots. And the third pack of pilot lines for nano-enabled products, offering nano-enabled injected cast parts, RTM polymers-based composites, nano-enabled aluminium composites hybrid products, and nano-enabled pultrudates. Graphically, when a client knocks on the OASIS single entry point looking for light and multifunctional structures, the client access to a network of facilities and services. The client will find an ecosystem of 12 pilot lines operating under a sustainable manufacturing framework that aims at ensuring a competitive, quality, safe, and environmentally friendly production of nano-enabled products. Second, technical services, going from primary concept to final qualification of the product, including material selection, manufacturing processes, product and process design, modeling, characterization. In addition, specific services related to nanotechnologies such as sustainable manufacturing diagnosis, environmental and nanosafety, safe by design approaches, and also life cycle analysis for when recycling concerns come to the scene. And third, the client is finding business support services to understand market needs and accelerate market commercialization of the product developed. When the client leaves the OASIS or Open Innovation Testbed with a solution, he feels he got more than expected. With a feeling that the whole development chain was covered, the structure developed is a business opportunity, can be commercially exploitable, and potential investors have been identified. The most important thing is the client will probably be back in the future due to the unique combination of products and services the single entry point OASIS is offering. One of the strengths of the project is the group of 6 global leaders representing high-impact sectors: mobility, transportation, construction, packaging, and energy, that will implement in real cases the materials and components developed through the 12 pilot lines and associated services. These companies will work on 6 showcases. These companies are the Open Innovation Testbed clients. These companies are knocking on the OASIS single entry point and are looking for light and multifunctional structures. The showcases target specifications that will be reached by 1 or 2 or 3 or more pilot lines. In terms of products, specific services will be defined and developed for each of the 6 showcases. Several key performance indicators for the OITD have been identified and will be validated through the development of the showcases. The success in reaching showcase specifications, in fulfilling the KPIs for the Open Innovation Testbeds, and in receiving a positive impact from the companies will be an indicator for the pilot lines offering the light products and associated services. 6 global leaders are developing real cases to validate the pilot lines and the services. The single entry point will be ready as a one-stop full package offer for the European industry. Well, now the OASIS SEP is ready and the OITD has been opened to the industry through an open call. To foster innovation in key industrial sectors and support the development and market uptake of key enabled technologies, companies will develop Democases, will access specific services to develop multifunctional nano-enabled products. So companies like new SMEs, industries, individuals, academia, RTOs will be attracted through this open call, and companies will have the opportunity to develop Democases during 6 months, develop specific demonstrators, and also access to specific services, technological services, and also business support services, always to develop multifunctional nano-enabled products. Well, this is the purpose and the essence of OASIS, and now I pass the word to Ramona. Ramona will explain how the open call works.
Yeah. Thank you very much, Sonia, for this very interesting introduction. Before I jump on the open call for Democases, I have 2 more questions for you. The first question is about the technical services that Sonia just explained. So we are curious to know which of these services raise your interest the most.
Sorry, Ramona, am I sharing the screen or are you already?
No, we have for the moment. So for the moment we have the poll open, but I take back the screen in a minute. Right.
Okay.
So I think we can in the meantime ask the second question about the business services. So Sonia has already explained that there are different types of business services that you can benefit from during the support for Democases. Okay, we leave you 5 more seconds to vote. Okay, thank you. So, now that you got the brief introduction of the setup of the OASIS project, I will explain you the open call for Democases. With its open call, OASIS provides support to different kinds of European organizations to develop and test new nano-enabled products. And this will happen by taking advantage of top-notch European infrastructure. But we have to highlight that the OASIS support is not just focusing on R&D, it's really about transforming a product idea into a functional product and thus develop an exploitation strategy that targets early market adoption. So you should be really aware of that part. In more detail, being selected as an OASIS demo case includes that all successful applicants will get free access to the ecosystem of the 12 nanotech pipelines that were just explained by Sonia. And we are completely aware that these 12 pilot lines, all these business services and so on is quite a lot. So no worries, you are not alone. You will get support in selecting and organizing all these support services. So OASIS really provides you with a customized support that matches your needs. You will get a complete set of technical and business services covering the implementation and exploitation of your product idea. To summarize, when you will get selected as an OASIS demo case, you will benefit from free of charge contribution, including qualified human resources for the execution of your demo case, the consumables and the materials that are required for the implementation of the demonstrator, and of course the access to top-notch equipment and infrastructure provided in these 12 pilot lines. So who can actually apply to this open call? So that's really the nice thing about the OASIS Open Call. It's really open to all organizations, regardless their type, size, or their industry. So here we have listed some categories from which you can select in the application form. So all types of for-profit private companies can apply, and this includes SMEs, but also research organizations, higher education, institutes, public bodies. When you don't find yourself in these categories, then we also have the one called others. But regarding the who, we have to highlight one thing. So OASIS aims at fostering the competitiveness of European businesses, and this includes that SMEs are the primary target of this open call. So a minimum of 50% of the business cases will be dedicated to SMEs. If an SME reaches a score above the required threshold in the evaluation of applications, it might take the priority over a proposal from another type of organization that's originally ranked higher. So just be aware, but as we have 75% of SMEs with us today, I think this is good news for you. So after the who, we have to speak about the when. So in June, we have launched the open call, and this will be open until July next year. And during this application phase, we have 2 cutoff dates. The first one, as you see, is end of January, the second one, end of July. Another good news for you, you can directly start working on your application after this webinar and adapt it over the next month. As soon as you hit the submit button, you will not be able to include any changes afterwards. So take your time, work on your application, and then before January 31st, click submit. When you have submitted or in case you have submitted your application before the first cutoff date, we will do a first check within a week. So if your company and your application are identified as eligible, there will be 4 weeks planned for the technical as well as the business evaluation of your product idea. And by mid-March, the internal OASIS evaluation panel will meet. And this panel, so if this panel approves your application, the assignment process as well as the setup of the service delivery plan, so here you have written SDP, that's service delivery plan, will start. So for this part, we consider 6 weeks to finalize. So in the end, if you submit your application by end of January, your demo case project should start end of April. Some more information regarding the evaluation process. So each submitted proposal will be evaluated by 2 technical and 2 business evaluators. You can reach a maximum score of 15 points. The standard overall threshold is 10, and the one for individual criteria is 3. So that's about the evaluation on the proposal level. But in OASIS, we also have to check the portfolio level. So this means that the evaluation panel will take additional considerations into account, and this includes if all the services that the consortium is providing are balanced, but also if there are actually capacities available to execute the demo cases that have been selected. So now have a look how you actually apply. So you already did an important step today in attending this webinar. Nevertheless, we recommend you to visit the project website and have a closer look on the catalog of services, as well as the application guidelines. As you see, when you get the link to this presentation, you will have a lot of links here that will help you in preparing your application. For starting your application itself, please register in the submission software on the project website and complete the application data. And there, pay attention that you have to include preliminary technical and business services. So when this is done, it's quite easy. Just download the application form, complete it, and the very last step is to save it as a PDF, to upload and submit through the software on the website. If this sounds a bit confusing for you, I have another good news. You are not alone. So during the whole application process, if you need assistance or explanations about possibilities, about the different services, you can reach our help desk by phone and by mail. The help desk is active from Monday to Friday, from 9 to 5 Prague time. So the last information about the open call from my side is that OASIS has a special offer for applicants to check the technical but also the business feasibility of a project idea before the final submission of your application. So if you want to use this service, please contact the help desk. So that's all from my side about the open call. If there are still questions open, please use this opportunity and write your question down in the question box, and we come back later to it at the end of the webinar. Now I have the pleasure to hand over to Javier, who will introduce our first showcase example today from Acciona. So you're presenter now.
Okay, cool. Okay, hello, good morning to everyone, and thank you very much, Ramona, for the presentation. Everything was really clear. So first of all, before starting with the presentation of Acciona showcase, I would like to thank you for attending to this webinar. And I hope that at the end of the webinar, you decide to follow Ramona's suggestion and apply to this to the open call, because I think that is a great opportunity to work with some of the state-of-the-art research center and research groups in Europe to further develop your project. So now I will start with my presentation of the showcase one. I think that now you can see the presentation. So I'm Javier Sacristan, as I said, from Acciona, and I would like to give you a very quick overview of what is Acciona.
I don't see your screen.
No. Okay, 1 second. Now?
Yes, perfect.
Now it works? Okay, great. Sorry for that. So I would like to give you before starting with the discussion of the showcase, I would like to give you a quick overview of Acciona, what we are and what we do. Acciona is one of the Spain's leading corporation with 4 major business lines: renewable energy, sustainable infrastructure, water, and services. It has more than 39,000 employees in 65 countries in 5 continents. And Acciona Construction is at the forefront of research and development and is one of the leading construction companies in the world. In 2018, we invest more than 200 million of euros in these activities, and in 2019, this figure was a little bit higher. In Acciona, innovation, research, and development are synonymous with sustainability. We work to transform ideas into new, efficient technological developments to help build a sustainable future. In this context, few months ago, 18 months ago, we decided, or a little bit more, we decided that participating in OASIS, it was the best decision that can be taken to further develop more sustainable, lightweight material and processes for the construction sector. In fact, we already have an extensive experience in the use of fiber-reinforced polymer composite for civil works. We are, in this project that I showed you in this slide, we are responsible of the design, of the production of the different elements in our facilities, installing the different elements, and also exploiting, as you can see, very different type of infrastructures made with composites. The first picture corresponds to a pedestrian bridge made by resin infusion in just one shot. The second picture corresponds to a cladding panel for high-speed railway tunnels. These panels are installed in the north of Spain. The third one is electromagnetic transparent reinforcement rebars. In this case, we installed these rebars in the Sabadell subway line. The next corresponds to the first lighthouse made 100% using composite materials. It was done in our production facilities here in Madrid, and it's installed in Valencia, in the port of Valencia. And finally, we also are able to design, to produce, and to install modular structure, modular trusses for building, for bridges, and different structural applications. So now, the question is, what are the challenges that Acciona proposed to OASIS? We are aware that in the most civil engineering structure, corrosion is the main enemy and is the leading cause of premature failure. The annual direct cost of corrosion in the US is estimated between 6 and 10 billion of euros. In principle, it's clear that a good concrete is supposed to provide adequate protection to the embedded steel. But over the passage of time, due to several chemical and physical processes, the pH value of the concrete decreases very slowly, initiating the corrosion process, which in turn causes cracks and spalling of concrete. It's true that there are several options commercially available to solve this problem, such as applying coatings to the concrete element, increase the concrete thickness to retard the water penetration, use steel rebars protected by coating, epoxy coating mainly, or stainless steel rebars. And last but not least, use fiber-reinforced polymer rebars. All of them have some advantages and disadvantages. From our experience, fiber-reinforced polymer rebar are one of the best alternatives to steel rebars, and in many countries, conventional steel rebars are slowly replaced by fiber-reinforced rebars in very specific projects due to its high strength-to-weight ratio, corrosion resistance, durability, and better stiffness than conventional steel rebars. However, the use of fiber-reinforced polymer rebars still presents many challenges regarding processability, inline quality control, long-term durability in very aggressive environments. Also, the new strictest regulations and standards are a problem for existing fiber-reinforced polymer rebars, and the higher cost of the composite rebars compared to the steel rebars. So, in OASIS, we propose to develop a state-of-the-art multifunctional fiber-reinforced polymers composite rebars with enhanced fire retardant and corrosion-resistant performance. At the same time, we are also interested in optimizing the production. In this case, these rebars are produced by pultrusion, increasing processing speed and minimizing energy consumption, which will have a direct impact on the final cost of the rebars. In addition, a nano-enabled corrosion-resistant coating is being developed to impart extra protection to concrete elements in very aggressive environments. In this showcase, there are 5 partners involved, 5 pilot lines: Fraunhofer IGCB, Fraunhofer ISC, Castilla-La Mancha University, Tecnalia, and CEA. They are in charge of fully develop and validate the OASIS solution to this challenge proposed by Acciona. In this showcase, the entire process chain is covered by OASIS partner. Fraunhofer ISC developed several types of nano and microparticles to enhance fire resistant, corrosion resistant, mechanical performance, and curing speed and degree on fiber-reinforced polymer rebars produced by Fraunhofer IGCB. They are focused on processing the rebars by pultrusion using an injection chamber, incorporating the nanoparticles into the resin formulation, and curing the resin using a combined system of infrared radiation and induction, thanks to the use of magnetic nanoparticles. On the other side, Castilla-La Mancha University works on developing the nano-enabled coating system to protect concrete from water infiltration in field conditions and extend its service life. Validation tests are carried out by Acciona and Tecnalia, and as we are using nanoparticles in an industrial environment, CEA takes care of all nanosafety issues at both lab and industrial scale. Up to date, Acciona has received several types of OASIS rebars with and without nanoparticles. In general, their properties are much better than the reference samples, and in fact, these rebars already meet some of the key performance indicators set up at the beginning of the project. They have higher glass transition temperature, higher fiber volume fraction. This means that it's likely that their mechanical properties will be also better. They have also a higher curing degree, and hopefully we haven't reached yet the 20% final cost reduction, but we are close to this value. And also with the energy consumption, we are about 10% less energy consumption than using the traditional or the starting parameters. And regarding fire retardancy, we're still a little bit far from this value, but we are beginning with the new testing the second batch of rebars with up to 30% in weight of fire retardant nanoparticle during the next week. So hopefully we will reach this value in the next weeks. So once the fiber-reinforced polymer rebars have been fully characterized at the rebar material scale, the next step is to integrate them in concrete beams and evaluate their mechanical and fire-resistant performance. In this showcase, there are a very close collaboration between the end user and the pilot lines. For instance, Acciona defined geometric dimension of the sample for each type of test, either mechanical or fire-resistant test, installed the different type of sensor to measure the formation and temperature in different parts of the rebar during testing. And after the test procedures and results are shared among all partners involved in this showcase. And this helps to improve and get most valuable and meaningful information for the next round of tests. Finally, fire-resistant tests were performed at Tecnalia facilities under sustained flexural loading until failure. These pictures were taken at the beginning of the test, the picture on the left, and at the end of the test, the pictures on the right side of the slide. From this picture, very valuable information can be extracted, and it would help to further develop the final solution, thanks to the collaboration between Fraunhofer ISC, Fraunhofer IGCB, Tecnalia, and Acciona. In parallel, Castilla-La Mancha is developing a nano-enabled corrosion-resistant coating to further protect concrete reinforced beams in very aggressive environments. They are optimizing the coating formulation and the coating process. They are using different types of nanoparticles, going from nanosilica nanoparticles to titanium dioxide, and also different types of amorphous carbon particles. These coatings are validated at lab scale by means of several tests: Tabor abrasion, accelerated aging test, adhesion, water absorption test. Acciona has prepared different types of concrete specimens for testing, and is also carrying out the Tabor abrasion test and the accelerated UV test on the concrete samples coated with the coatings developed by Castilla-La Mancha University. Finally, once rebars and coating have been validated at lab medium scale, the most promising ones will be selected, and new concrete reinforced beam will be cast at Acciona facilities and demonstrated in a real environment. In this case, we have selected the port of Gijón in the north of Spain. Concrete beams will be in contact with seawater from 12 to 24 months, and after that time, mechanical and fire-resistant tests will be performed to determine their final performance. Once OASIS rebar are fully validated, they will give Acciona the possibility to open new markets, replacing steel rebars in reinforced concrete in many projects in aggressive environment, because the OASIS rebars will be more durable, more cost efficient, and heat resistant. And obviously that will also help to widen the market for these composite rebars. And that's all from my side. If you have any question, I will be happy to answer it at the end of the presentation. Thank you.
Thank you so much, Javier. I don't take many words. I directly make Stan our next presenter, so we can directly continue with the automotive example from VDL.
Okay, perfect. Thank you.
So Stan, we see your screen, but I don't hear you for the moment.
Hello, welcome. Welcome, everyone.
Perfect.
Well, as you mentioned, can everyone on my screen?
Yes, we see it and we hear you.
Okay, perfect. Well, welcome. We as VDL Fibertech Industries are part of the VDL group. VDL is mainly focusing on automotive and a supplier of well, different components to all sectors. We as VDL Fibertech, I'm sorry, but I can't. I'm sorry, I'm showing the presentation again. We as VDL Fibertech are well, focusing in the VDL group on the composite sector. We are mainly focusing on RTM manufacturing, which is resin transfer molding, and thereby we focus mainly during development on structural components. Within OASIS, we would like to we are focusing on a multifunctional composite panel, which is also a structural part. And the benefits we have from OASIS is the reduction of cycle time, because we would like to produce it in a high volume. We would like to reduce the cycle time by 15%. We have to decrease the final product weight. and that's mainly due to the electrification of vehicles. Because the lighter the vehicle, the less energy it takes. To increase the thermal comfort, thereby also lowering the energy consumption, which increases the range. We would like to have a fast verification of the control monitoring, as well as in our process as in the final product, which I will explain later. And preferably, we would like to have no increase in costs. Well, to reach these goals, we combine 7 pilot lines of the complete OASIS consortium. 7 is quite a lot for one showcase. Thereby to reduce the cycle time and well, the fast verification of the monitoring, we would like to incorporate some functions. We will do this by strain gauges. So strain gauges will measure the elongation, etc. And then we can well, check and see if the panel is damaged. And we would like to incorporate thermocouples and touch sensors. And thermocouples will be used inside our own manufacturing process to control the temperature inside the mold. And if it has a certain temperature trajectory during processing, we know the part will be cured and we can take it out of the mold, which reduces the cycle time and the in-mold cycle time of the final product. Thermocouples we will also use in the final product to measure the temperature inside the vehicle. Touch sensors are also used in the final product, and they combined will lead to a reduction of assembly time later on. So we will assembly everything at once, infuse the project with resin, and then in the end we don't have to take it to another production step to assemble it any further. We would like to integrate materials to decrease the weight and to increase the thermal insulation. Together with TMBK partners, we are integrating a carbon nanotube doped field to increase the impact resistance. And at the moment, we already gained an improvement of 9%. It will act directly as finishing layer to prevent print through of the more structural fabrics that are underneath, because the final product needs to have a nice finishing. And although we have to incorporate more material, which might increase the cycle time, we are integrating the fields onto the fabric, so it can be taken as one part, place it inside the mold, and the complete cycle time won't be influenced by that as much. The increase of thermal comfort, we would like to do that with aerogel foams from UCLM. Well, therefore, we don't have to put that much energy in to, well, keep the temperature as we would like. And we would like to incorporate bucky papers as heating elements. And these are, well, resistive wires. And therefore, we can heat up the vehicle without using a big heater, as is done at the moment. We would like to integrate fire retardancy powder, just to increase safety in case the vehicle is burning. Well, we had some difficulties, but well, we overcome. Well, we did solve those problems because it affected the permeability of our process, and we are not sure about the mechanical strength, but that will be validated later on. well, to justify all modifications we made, we would like to increase, and we are simulating well, the modifications we made. We would also like to increase and to optimize the strength, because the better and the more optimized our design of the final product is, the less material we need, which decreases weight, etc. Thereby, we would like to decrease the cycle time as well. Therefore, IPC is doing a simulation of the curing cycle, and well, the shorter our curing cycle is, the faster we can produce those panels, because these the infusion step, so the resin injection, is at the moment our most critical step. Nevertheless, well, we use simulation, but in the end we have to validate that those simulations are representative, well, for the reality. Therefore, we did some mechanical testing, and we did this mechanical testing on all materials, functions, etc. we made earlier on. Also, the safety of nano-enabled products is important to us, because, well, we are a production company and not a research institute or etc. Therefore, CEA is taking the lead on nano safety, and they are looking especially what we desire. And for us, it's important to how to store the nano-enabled products, the safety of the operator, so what can be released during production, or even if the final product is in a crash situation, burning, etc. Also important, the disposal of waste. Well, because there are nanoparticles, carbon nanotubes, etc. in there. And of course, everything has to be must comply with the regulations, as well European as worldwide. And for VDL Fibertech Industries, our main advantages of attending the OASIS product is that there is a direct link from the raw material to the final product. So on the complete during the complete development trajectory, we do have the partners that are experts on the really small scale, up to the companies that know how to integrate those materials in the final product. So on every level, from start to finish, well, there is some expertise. Before we go into full production, we are producing a lot of samples, see which combinations are possible, and therefore de-risking, so we don't have to do that afterwards. For Showcase 3, IPC and VDL are working close together on the integration of the integration and combining all those nanoparticles and well, technologies of all pilot lines, which helps to communicate fast and, well, to solve a problem at no time. We as a production company, our network is more based on customers, well, production, etc. Not so much with research institutes and gaining knowledge. So also the OASIS project helps us to easier and further develop, well, new technologies into our products, which of course has an advantage business-wise. Well, and here at the bottom, the benefits we have from the OASIS project are once again mentioned. And at the moment, we are still able to reduce cycle time, to decrease the final product weight, to increase the thermal comfort, have a fast verification of the control monitoring, and no increase in costs is achieved by the nanotechnologies itself increase costs because they are quite expensive. Well, they make the complete process well, more difficult. But through the decrease of the final product weight, therefore reduction of cycle time, etc., well, it compensates approximately well each other, and therefore it's looking quite good to have no increase in costs. Thank you very much. Hopefully it was clear. If you have any questions, I would like to answer them.
Thank you, Stan. It was crystal clear. Also, thank you for highlighting the advantages at the end. I would now directly give the floor to Gregory, who is connected by phone. So I am his slide girl, let's say. Gregory, floor is yours.
Yeah, you hear me?
Yeah, we can hear you.
Is it okay? Okay, perfect. So good afternoon, everybody. My name is Gregory Pognon. I'm in charge of the energy storage topic within the Thales Research and Technology Center, but I will represent today Thales Avionics that request the different developments we are doing in this showcase for smart nanocomposite casing for an avionic battery module. I put here in this slide the logo of the different partners that are involved in this particular showcase. The three main pillars, Thales, CEA, and IPC that are developing and producing the systems, and also the three other pilot lines that help us to improve the properties of our systems, Technalia, Fraunhofer, and Adamant also. Next slide. To begin, I just would like to say a few words about Thales. We are a French multinational company specialized in the development of high performances electronic systems and software in the surrounding domains such as aerospace, space, ground transportation, defense, and security. And our avionic global business unit ask us today to develop a new kind of energy storage system. You can move to the next slide. In fact, they are in charge of development of the electrical power generation systems you can find in the different civilian airplane today. And for the specific 787 Dreamliner, they choose a battery pack from GS USA, a Japan company, that select finally a specific lithium technology, lithium cobalt oxide technology, that in certain condition of utilization in the Dreamliner can suffer from a progressive degradation of the material inside, and finally everything ends up burning flame inside the plane. That's the problem. In order to solve this problem, GS USA proposed to put this particular battery pack into a supplementary titanium enclosure in order to contain the thermal runaway while the plane is still flying, and let the smokes go outside of the plane, and the plane can continue flying because there is a secondary battery, exactly the same that this one that can take the relay of the problem. The battery is the problem. But the problem with this kind of approach is that we increase a lot the total weight of the battery pack. That's why we are here today. Next slide. In order to find a new solution for lightweight safe and robust casing for battery module based on nano-enabled composite material, but also on a whole network of integrated sensor for inoperant diagnosis of the battery module. So we have two axes of innovation. The first one concerns, of course, the nano materials that will help us to improve the mechanical and thermal properties in order to be able to contain the thermal runaway and also further reduce the weight in the structure. For that, we have benchmarked a lot of different products from the pilot lines. We are also working on the integration of a whole network of thin film printed sensor, providing us some information of the state of health of the batteries, for example, in order to be able to prevent the thermal runaway before it starts to happen. And then we have three main technical KPIs. The first one concerns the gain in terms of energy density, up to 20%. The second one concerns the resistance to the thermal runaway of one cell inside our casing. And the last one is for the ability to detect thermal runaway before it starts. Next slide. Here is the concept of our approach. We want to produce this kind of battery module pack casing where we can put together in parallel up to 16 small cells in order to avoid the propagation of the thermal runaway between cells inside. And also we want to implement a sensor in the wall of this casing, but also directly on the cells, on the red parts you can see on the picture. And the concept is that we can plug in serial this kind of module in order to furnish the right energy density for the global pack. In this way, we will not have additional weight due to the casing of the whole pack, because the casing of the module will constitute the final casing of the pack. Next slide. Here is the organization of the work we do. As I said before, we are 6 involved partners. Thales and CEA take care of the batteries and the casing design, initial design, while other pilot lines are working at different level of maturity, from nanoscales, for example, with Fraunhofer that developed fire retardant nanoparticles for us, that could be included into prepreg by Idamont before letting the IPC characterize them for the selection of the raw material we want to use in the casing. In parallel, CEA works on the production of the sensors, and the IPC is producing the casing by making some adjustments depending on the material or the process. And finally, everything is assembled at CEA for a test in relevant environments. We also ask Technalia to help us in order to be able to have a reference casing, the same kind of casing, but made of aluminium, in order to appreciate the gain in terms of weight compared to the more classic technology, I would say. Next slide. Now we are globally at the middle of the project in terms of duration. We also succeed to do 50% of the planned work. For example, we already select and evaluate the different raw materials. We select multiple ply of carbon and glass fiber with PPS matrix, plus overmolding in PPS glass in order to reinforce certain parts of the casing. We also did the different electrical, chemical, mechanical characterization in order to be able to do simulation of the behavior of our materials inside the casing, in order to check if we will contain the thermal runaway. We also already select the sensor, their location inside the casing, but we are still working on the design now. We choose a printed thermocouple on Capetone for the sensor we want to implement inside the wall of the casing, and printed PVDF acoustic sensor directly on the cells. Now that we validate the global final module design, we started the fabrication of the mold for the production of sorry, 2 half cylinder and 1 bottom or top lid plus over molding. And the simulation already show us that we can expect 88% of gain in terms of weight if we compare to the current technology using the titanium enclosure, and also that we can contain up to we can resist up to 20 bars. That represent a lot of more than the pressure released by the thermal runaway of one cell, which is only 6 bar. So everything is okay concerning KPI for the moment. And if we compare to the reference casing made of aluminium, we still have 15% of weight of the casing. So now we plan to do the same kind of characterization, but on processed materials in order to confirm that we will resist to the thermal runaway. Finish the design of sensors and also of the batteries inside the casing. Validate the mold by producing the first pieces and putting everything together in order to be able to do some tests in relevant environment at CEA. Finally, next slide. I would like to say that we requested a lot of different services from the catalog you can find online on the website of the OASIS project. Not only purely technical services on materials or processes, but also services on design, modeling, simulation, and characterization, and also one non-technical services for business support in order to do an exploitation plan at the end of the project. Finally, I would like to say that we are very happy with this project, not only because we already defined a quite unique nano-enabled composite smart casing reaching our KPIs, but also because we have a direct access to the most relevant and advanced solution for this casing, but also for the future other projects within the Thales group. And also we are very happy with the fact that we now integrate a new network of specialists in the composite material. And well, I thank you for your attention.
Thank you very much, Gregory, for all these insights. We are completely aware that we are a bit late in time, but anyway, I would like to give you a brief outlook. So today you have heard the introduction of three showcases. Those of you who attended the webinar in July have also heard the showcase of Fault. For the others, you can access it on the project website. And in November, we will all meet again to listen to the showcases of Airbus and Pleione Energy. So I have 2 more questions for our audience, actually, which are very interesting for the whole consortium. So the first is, do you plan to apply? Okay, we leave you 5 more seconds. Okay, I think our consortium partners are very happy to hear that 70% of the participants are planning to apply for the Democases. And so during the open call explanation, I have mentioned that we have this feasibility check for applicants. So do you plan to use this? Okay, wow, that's how do you say it in English? I mean, so 95% are planning to use this feasibility check, so it shows as a very good offer from the project level. Okay, thank you all for providing this input through these little polls. It's time to thank everybody for attending this webinar, especially our 4 speakers today. And I wish you all a great week. So see you in November for the next webinar.
Thank you very much, Ramona.
Bye-bye.
Bye.
Thank you. Bye.
Thank you.